Okay, hi guys. This is the first video. I hope everyone's doing well, first of all. Um, and that you're spending time with your family and that you're feeling healthy and happy. This is the first video of the rest of the year, like that we still haven't covered. I'm gonna go like super at a super efficient pace. Okay, so how many more days? We just have two more. I'm looking ahead. We have two more videos for cycle J. No, three more videos for cycle J. That's what we were on. And then I'll move on to antiderivatives, which will be like, that's basically what we haven't covered. And I should have locked my cats up because they're going to bother me. But okay, so a particle moves. All right, so cycle J practice or phase 4. The practice for this is on delta math. For these phases that are coming, some of the practice is going to be like on the paper, but other stuff will be on delta math. So this practice, you go to delta math and you look at cycle J phase 4, and there's practice for this. So a particle moves along the x-axis so that any time t greater than or equal to 0, its velocity is given by this. Determine the speed of the particle at t equals 1. So you need to know that the speed of a particle, so the speed of a particle at any time t equals the absolute value of the velocity at that time. And you might say to yourself, oh yeah, we got to take the derivative because the velocity is the first derivative, but this already is velocity, so you don't have to take a derivative. So you just, so the speed at 1 is going to be equal to the absolute value of the velocity at 1. All right, and then this is going to be equal to the absolute value. I'll find the velocity at 1. So the velocity at 1 is just 3 minus 22 plus 35 is 16. The absolute value of 16 is just 16. And they're not giving us units, but maybe it's miles per hour, who knows. Okay, so if this was x of t, we would need to take the derivative first and then use the speed formula, which is just absolute value of velocity. Okay, this next one. A particle moves along the x-axis. Okay, so basically the same situation every time. This is the particle. This is not velocity. This is the particle's position. Determine the acceleration of the particle at t equals 3. Acceleration is the second derivative, so you need to know that. So you need to know that the acceleration at 3 is the second derivative of x at 3. So that's basically what you need to know. So the first derivative is velocity. Yeah, so the first derivative is velocity. So x prime of t, or you could go right to v of t. You could probably hear my neighbors. Okay, so this would be velocity. All right, but we want acceleration, so I'm going to go x double prime of t, and you could go right to a of t, and then taking the derivative of this, negative 6t plus 30. Okay, so we've got acceleration at 3 is negative 6 times 3 plus 30. Negative 6 is 12. Okay. Now this one, a particle moves along the x-axis, so same position, same situation, I mean. The position is given by this function. Determine if the particle is speeding up or slowing down at t equals 6. Explain. Now, in the material that I sent you of what we've done so far, this is one of the, so here's all of our, like, tables that tell us the information or the relationships between f and f prime and f double prime. So we've got these two tables, and then we've got this one, or this is like the physics version of the stuff above, basically. So they are asking, determine if the particle is speeding up or slowing down at t equals 6. Explain. So guys, if you go down here, there's two situations for a particle speeding up. Either velocity is positive and acceleration is positive, or velocity is negative and acceleration is negative. All right, so those would be, there's velocity and acceleration. So first derivative, second derivative. So basically we got to take the first derivative, which would be velocity, see if it's positive or negative at 6. Take the second derivative, which is acceleration, see if it's positive or negative at 6. And then if their signs match, speeding up. If their signs don't, slowing down. All right, so we want to see if it's speeding up or slowing down. Oh, yeah. Just slowing down would just be, you know, that they have opposite signs. So, yeah, so I'll go v of t. Okay, so v of t is going to be the first derivative. All right, and then the acceleration, second derivative. All right, so the velocity at 6. Okay, so it's positive. And then the velocity is. Okay, and then this is negative. All right, so the answer is slowing down. And then I'm going to say it like this, because v of 6 is greater than 0 and a of 6 is less than 0. But actually on delta math, they're going to guide you through an explanation on delta math. And I think their explanation would be like, because I think that delta math would say, or because v of 6 and a of 6 have opposite signs. I think delta math will guide you more toward that. Okay, guys, so get in some practice. But at this point, you know, we want to go kind of as fast as we can. I don't want you to like cram, but you want to move through this as fast as you can because of the, you know, because of the weirdness of this time right now. Yeah, please let me know if you have any questions at all. I will get right back to you.